Alright, hello, welcome back. Thanks for watching this video about how to finish this worksheet. Parts A, again, you need to use this chart, which you should have in your notes. Again, that's this chart right here. You should have that in your notes, and you're going to use that chart to help fill in these blanks, these gaps right here. Just so, in case some of us are still a little bit confused, again, you're using your notes to see if this statement either applies to either one of our betas, our alphas, or our gamma radiations. And for number 4, where it says nuclear decay with no mass and no charge, the only one that does not change the mass and does not change the charge is gamma. So we'd write that down here. So for these parts here, these parts should be in your notes on the slides so you can find their answers. But for part B, you're going to need a little bit of assistance here. Now, alpha, beta, and gamma. I want to show you how that basically looks like. So for our alpha, in an alpha decay, how that looks like here is that you're going to have your radioactive element, which is going to be, in this case, uranium. So we're going to draw it in isotopic notation, which is here, and it's going through alpha decay. So we're going to see our alpha particle right here, and after that, we're going to see a new element entirely. And in this case, it is, I believe, thorium from uranium. Now, this right here, that is your alpha particle. In a beta particle, or a beta decay, that looks something like this. Again, you have a radioactive isotope. In this case, this is going to be iodine, and it's going through beta decay. This right here is a beta particle. So if you see that, just know that you are undergoing beta decay. After the beta particle gets kicked off, then remember, during a beta particle, beta decay, that one of the neutrons becomes a proton. So instead of having 53 protons, now we've changed one of our neutrons into a proton and it became 54. And lastly, our gamma radiation. In a gamma radiation, it's similar to our alpha, but we're going to add something this time around. So uranium is radioactive. It's going to still give off a alpha particle, like so, just like we did in our alpha decay. However, this time, we're going to throw in our gamma rays. Yeah. This right here, that's your gamma rays. So that's how our alpha, beta, and gamma particles will look like. So again, so you have this down, and remember to pause. I'm going a little bit too fast. If you go on to the next slide, you can see that we have some radioactive decay reactions. And here you need to fill in those blanks. So I'll go through an example here. In number 1, we have tungsten. And according to this, remember, if we're seeing this symbol, we know it is an alpha particle. So this has to be going through alpha decay. When we're trying to predict our new blanks, you have to make sure that the top numbers and your bottom numbers, when put into equations, all add up. So let's try the top numbers. If we were to make this an equation, that would be 184, equals 4 plus blank. We don't know what that is. Well, you can subtract 4 from both sides. Subtract 4. And we get 180 is equal to our mystery number. So we can place that here. For the red numbers, again, 74 is equal to 2 plus our mystery number. Again, we need to get rid of that 2. We want that mystery number by itself. So this is 72 is equal to our mystery number. Now that we have our numbers, right, the main important number, right, is this guy here. That 72 can tell us what kind of symbol to use. If we look at a periodic table and find 72, right, that is right here. Hafnium, HF. So now that we know that, right, we can put that down, and now we have our answer. You want to do the same thing, all right, for numbers 2 through 6. We can try to see if those numbers will add up. Figure out what these numbers will be, and then you can predict what symbol to use. Okay. And the same thing, if you go to the next part, you'll still need to, again, predict which of the following need to be placed in here, and if it's alpha, beta, or gamma. So let's try one more example. Okay. I want to make sure our top numbers and our bottom numbers, all right, when added or subtracted, all make sense. So let's see. For our orange numbers, we have 42, arrow, that's basically an equal sign, equals 0, plus the new number that's supposed to go right here. Well, 42 equals 0 plus question mark, that's looks like 42. So we didn't have to do too much for that. 42. Right, but again, for the red one, looks like we have 19 is equal to -1 plus question mark. For this, if we were to add 1 to both sides, we get 20 as our result. So we know the atomic mass, we know the atomic number, we just need the symbol. So again, if we know the atomic mass, or sorry, atomic number is 20, we find 20 on our periodic table, and that is Ca. So we can write that down, Ca. So we have our blank filled in. The only thing now is to recognize whether we went through alpha, beta, or gamma. I don't see any 0, zeros, and a Y, so it's not gamma. Right? For it to be alpha, I need to see 4, 2, and a helium. I don't see any of that here. Right? But remember, beta is when you have an electron that's kicked off, so this is our beta decay. It says to describe the change that takes place, right? You have to describe what's going on in the nucleus. So remember, in beta decay, that's when a neutron becomes a proton. Again, beta decays when a neutron becomes a proton. I'm going to try that out for the rest of these here. Hopefully it wasn't too confusing. I hope you guys have a good day.